Hello chemistry. This morning I'm going to go over a predicting net redox example using complex half reactions. Alright, so I've set up an example here and it involves a breathalyzer test. So here's what goes on. Ethanol, which is the alcohol that is in beverages, reacts with an acidic dichromate solution. Alright, Cr2O7 is dichromate to produce acetic acid and chromium 3 ions. We got to predict the balanced net redox. Okay, so when you're doing this, start with just kind of what is called a skeleton reaction. So we know that ethanol reacts with dichromate to form acetic acid and chromium 3. All right, so these are the bare minimum entities involved in the reaction. What we're going to do is split this into two half reactions. Okay, and it's usually pretty obvious which reactant goes with which product. What you do is you look at your non-oxygen, non-hydrogen atoms to see what goes together. So this ethanol has a carbon, acetic acid has carbons. So that's going to be, I'll call it half reaction 1. All right, and now what we do is we follow the steps for completing complex half reactions, which there is a video for if you've forgotten those steps. I'll kind of slowly walk us through it though. The first thing you do is balance the non-oxygen, non-hydrogen atoms. So in this case, carbon, I got 2 on the left. Check it out, I got 2 on the right. Okay, so carbon's good. Next, we balance oxygens by adding water. So I got 1 oxygen, 2 oxygens. So I need to add a water to this side. All right. Now we balance hydrogen by adding H plus ions. So I've got 6, 8 on the left, 4 on the right. So I am going to need 4 H pluses. Again, these ions come from the acidic environment. If it was a basic environment, we would add OHs on a later step. All right, now that our atoms are charged, we just have to balance the overall charge. Okay. Did I say atoms are charged? I mean atoms are balanced. Okay, so this side's neutral, this side's plus 4. I need 4 electrons. Okay, that half reaction is now done. We got to do the same thing again for the other entities. So in this case, it's going to be dichromate becoming chromium 3. First step, balance the non-oxygen, non-hydrogen. So I got 2 chromiums, only 1 on this side. That's easy. Then I balance the oxygen by adding water. Okay, I had 7 on this side, so I'm going to add 7 waters. Now I balance the hydrogen by adding H pluses. This one's pretty simple to spot just because there were no hydrogens hiding anywhere. Okay, now we have to balance the charge. So let's just be careful here. This side, minus 2 plus 14, has a charge of plus 12. Okay. This side, there are 2 chromium 3s, has a charge of plus 6. All right, so I need 6 electrons here. And now both sides are plus 6. Just a reminder, you add electrons to balance the charge. You do not always neutralize the charge. Okay, so this has just been a bit of review so far because we've done this all before. And to finish the problem, you might have figured out anyway. What we have to do now is multiply the half reactions to balance the electrons, okay? So we're looking for like a lowest common multiple. This one's not too bad, 4 and 6. If I multiply this guy by 3 and this guy by 2, they'll each have 12 electrons. Okay, I'm going to do this one step at a time. So let me rewrite out HR1, but multiplying everything by 3. All right, now I'm going to rewrite out half reaction 2, but multiply everything by 2. Okay, so that's looking pretty good. Now we just bring them together. There'll be some things to cross off, and we'll get our net redox reaction. So you could efficiently do this by kind of crossing things off before you bring it all together, but I'm just going to smoosh everything and then figure it out when the dust settles. All right, so I got a whole lot of products and reactants, but lots of this stuff will go by the wayside. So the electrons should always cancel out, okay, because you balance them. H pluses and waters should certainly simplify. So I got 3 waters here, I got 14 over here. These guys go away. This is going to become an 11. I think you'll agree with that. And then the H pluses, these 12 will go away. I'll subtract 12 here. This will become a 16. So my net, my final reaction here, should look like this. Okay, I think it looks pretty good. I like to just take a look at charge quickly to make sure everything's balanced. So I got plus 16 minus 4 is plus 12 on the left. Clearly I got plus 12 on the right. You can choose any atom you want to just make sure it's balanced, but I feel really, really good about this. So this was a good example. It wasn't the most straightforward, and it should help you with your studies. Good luck.